Welcome to the third SOL prep video, looking at the same three standards: expressions and operations, equations and inequalities, and function and statistics, in order to get you prepared for the SOL coming up here in a few weeks in May. We're going to start with evaluating. So we're going to plug our numbers in. So we got 3 times the square root, 3 times the square root of 25 minus 2 times the absolute value of negative 4 times 7. Okay, so we have a lot going on here. Let's start with our square root. So the square root of 25 is 5. And then inside the absolute value, negative 4 times 7 is negative 28. 3 times 5 is 15. The absolute value of 28 is positive 28. 15 minus 2 times 28 gives us negative 41. There's a couple things to watch out for. The main thing is your negatives with the absolute value. So make sure you simplify the absolute value first. Once you simplified what's inside, then make what's inside positive. Number 2, we've got a polynomial problem here. We are multiplying, so that means we're going to have what's outside the boxes. So 2x plus 3 down the side, 3x minus 4 across the top. We're going to multiply what's outside to get what's inside. So 3x times 2x gives us 6x squared. 3x and 3 gives us 9x. 2x and negative 4 gives us negative 8x. And then 3 and negative 4 gives us negative 12. What's inside the box is going to be our answer. So we get 6x squared. Your diagonal should always be like terms, so we're going to combine those. 9 plus a negative 8 gives us a positive 1, or just simply positive x. And then we've got that negative 12. Number 4, we've got a cubed root here. So we're looking for groups of 3. So big number here. We're going to start small until we find something we're familiar with. So 3,456 divided by 2 gives us 1,728. So continue with that pattern, divided by 2. I'm going to run quickly out of space here. 864. Go again, and we get 432. We're going to go again and get 216. We go again and get 108. Another one more time gives me 54. Starting to get some smaller numbers here, so that's 2 and 27. 27 is not divisible by 2, so we move on to the 3. So we get 3 and 9. 9 is 3 and 3. Ooh, that's a lot. So we're looking for groups of 3. So I've got a group of 3 there, 3 2s, another group of 3 here, another 3 2s, and I've got a group of 3 3s. So from each group, I pull one outside. So I'm running out of space here. So what should we do? Let's go over here to the left a little bit. 1 2 from the first, 1 2 from the second, a 3 from the third. And then we've still got this guy left over. He did not have a group, so he's going to stay inside. We're going to multiply the 2 times 2 times 3, and that's going to give us 12. So our final answer would be 12 cubed roots of 2. So those first 3, those are our expressions and operations questions. Number 4, move on to the second category, which is equations and inequalities. We want to solve this, and then we're going to graph it on a number line. First thing I want to do is look to see if I can simplify. Here I can combine like terms. So I've got 6x and negative 11x gives me negative 5x. Negative 8 and negative 6 gives me negative 14. So now we can go ahead and start our solving. We're going to add 14 to both sides, giving us negative 5x is greater than or equal to 15. Divide both sides by negative 5, and we know when we divide by a negative, we're going to flip that inequality. 15 divided by negative 5 is negative 3. Setting this up on a number line. Because it's less than or equal to, we get that line underneath, we need a solid or filled in circle. And then it's less than, so it's going to go to the left. Moving on to number 5. What are the intercepts for the line 3x minus 4y equals 12? So the intercepts, we look at each individually. So our x-intercept, we're just looking at the x. Divide both sides by 3. So we get an x-intercept of 4 or 4 comma 0. And then for the y's, we've got, whoops, 3 again. Looking just at the y, we have negative 4y equals 12. Dividing both sides by negative 4 gives us y is equal to negative 3. So that would be 0 comma negative 3. So the answer should be A. Number 6, finding the slope. Slope is y2 minus y1 over x2 minus x1. So we have, whoops, x1, y1, x2, y2. Negative 10 minus a negative 9. And then we have negative 2 minus 6. Be careful with your negatives. The only time that these change to addition is like what we have on the top here, where we have subtracting a negative. So here we'd have negative 10 plus 9 because we're subtracting a negative, but on the bottom it's going to stay subtraction because we only have one subtraction sign. So on the top, negative 10 plus 9 is negative 1. There's the bell. On the bottom we have negative 8. We simplify a negative over a negative to give us a positive. So our slope would be positive 1 over 8. Moving on to number 7. Solutions, roots, and zeros are all found where the graph crosses the x-axis. So we want to graph this. We're going to put this into y1. And we're going to put 0 into y2. We're going to graph it and look for where it crosses the y-axis using the intersect command if we need to. So when you do that, you're going to get x equals 0.4 and x equals negative 6. When you graph this, you'll notice that it crosses the x-axis twice, so we should have 2 x-intercepts. Moving on to number 8, solving a system. A couple ways we can solve this. We can use our graphing method, we can use an elimination method, or we can use the substitution method. Here we're going to solve this. We're going to alter this a little bit. So let's say we want to graph this. We'd have to get y by, both these equations have to be y equals form so that we could graph it. If we wanted to use elimination, we'd have to both be in standard form. Or if we wanted to do substitution, one of the variables would have to be by itself. You can do any method. The easiest method here is going to be to use elimination. And we're going to do that by taking the second equation. And we need to move the x back over to the left. So that would give us negative 6x plus 4y equals, whoops, positive 2. Okay, so I'm going to get rid of that equation because I just took that equation and put it into standard form. First equation is already in standard form. So when I combine these two, negative 6 plus 6, that cancels out. 4 plus negative 4, that also cancels out. So I end up with nothing over here. And 6 on the right, well, 0 can't ever equal 6. So we know when that happens, we have no solution. Number 9, what is the range? We know range is y values. We're going to have to graph, so you need to graph this using your calculator. Because we're looking for the range, we're going to need to find the vertex. So when we do that, we find the vertex is 1, 3, and the arrows are pointing up. So we need the y value of 3, and we need it to be greater than. So our answer choice would be B. Number 10, what's the value of f of x when x is negative 2? This is simply plugging an x value in and solving or simplifying. So make sure you put the negatives in parentheses, because when we have negative 2 squared, that's positive 4. 5 times negative 2 is negative 10. So 2 times 4 is 8. 8 minus 10 minus 6 gives us negative 8. Number 11, plot point A at 4, 6. So remember, it's always x, y. So 1, 2, 3, 4, 1, 2, 3, 4, 5. So over 4 and up 6. There's our point A. So we need two other points to create a direct variation graph. Remember that direct variation graphs go through the origin. So the first point that I'm going to plot is going to be 0, 0. Second thing we have to note is that it's a straight line. So that means it has to have the same constant slope. So from the origin, I went over 4 and up 6. That's my rise and my run, so my slope is 6 over 4. So I can draw a straight line, or I can continue to use that slope, and I could do the opposite, for example. So rather than to the right 4 and up 6, I could go to the left 4 and down 6. That would give me another point. If you draw a straight line, you also have points here and here that also fall along that straight line, because the slope 6 over 4 can be simplified to be 3 over 2. So start here, because a direct variation graph always goes through the origin, and then you can use the slope to find additional points. Moving on to number 12. Change mean absolute to be standard. So the standard deviation, we're going to plug these data points into our calculator, into list 1. And then we're going to run 1 var stats. So it's going to go in list 1, and then you're going to go back to stat, over to calc, and you're going to do 1 var stats. In doing that, you should get your standard deviation to be 0.046. Number 13, we have some statistical information. We have the mean of the data set is 30, so that's our symbol mu. Standard deviation is 3, so that's sigma. And then we have our z-score is 2.25. So we're looking for x. So setting up our formula, z equals x minus mu divided by sigma. Z is 2.25. Our mu is 30, and our sigma is 3. We're going to multiply both sides by the denominator, giving us 6.75 equals x minus 30. Let's add 30 to both sides, giving us 36.75 equals x. And so we're going to look and say, well, 36.75, that fits in our final range because it's bigger than 36 and smaller than 42. Number 14, we've got a box and whisk plot to represent the batches of cookies that this baker's making over 7 days. On the 8th day, he bakes 20 cookies. We're going to redraw the box and whisk plot to include this data. We're looking for which one of these options is not true. So if he makes 20 batches of cookies, that's somewhere over here. We'll call this 20. So what this is going to do is going to pull all of these values, make them all a little bit bigger. I'll pull them towards that upper value of 20. So the median is going to increase. The lower extreme is still going to be 5. The lower extreme is not changing. So this should be our answer. The upper extreme, well, that's going to increase. It's going to be pulled towards, it's going to be 20 instead of 15. And the value of the interquartile range is going to increase. That's also going to happen. Everything's going to be stretched because of that value of 20. So the only thing that does not change is that lower extreme, or the minimum value. Number 15, we're once again using a quadratic curve of best fit. So you're going to put your x values into list 1, your y values into list 2. You're going to go to stat, calc, and because it says quadratic curve, we're going to do option number 5, which will be quad reg. So once you do that, you should get an A value of 1.7, a B value of 2.9, and a C value of negative 5.2. So your correct answer should be D. As always, don't hesitate to go back and rewatch any part of the video that I may have gone too quickly over. Or if you do have any questions of anything that I covered here or went over that still needs a little more clarification, make a note of that. The next time I see you in class, I'll be more than happy to go over this with you.